right? So we were talking about organic materials because they were initially discovered inside living organisms. They were later discovered inside the earth as crude oil and gases and so on. So they were organic. The other types of materials which are not based in living organisms in petrochemistry and so on, they are called inorganic materials. And all the rocks, right, all the different minerals and so forth are inorganic. So first of all, metals are inorganic. That is why we have to do mining, whether it is iron or aluminum and so on. We have to dig inside the earth, and of course first by geology and earth science we have to find where these ores are, where are the places on the earth where there is iron. Then we dig inside and we make mining processes and bring out. So this is inorganic materials. They have crystalline structure. If you remember, you see in the book, after the first 1 or 2 chapters, the first basic chapter of material science is crystal structure. So sometimes we start the course with crystal structure after introduction. But this time, if you see the way that I will be teaching, I will jump to chapter 6 in my counting, which is material properties. So therefore, generally people in a material science course would already know crystal structure. Here we will just tell you that all metals have a certain type of a structure in which their molecules and atoms are arranged. That structure is called a crystal. The other materials like ceramics and so on, or like non-metals, do not have their molecules and atoms arranged in that particular structure which is called a crystal. So this is important, that metals are inorganic. They are not like hydrocarbon chains and so on, and according to their atomic or molecular structure, they have special structures called crystal. These are 2 things. What is a crystal structure? We will study in detail when we go to that chapter. This is simple. You see, conduction we know. Thermal conduction means something which can allow heat to pass through easily, to conduct through it, and electrical conduction means something that will allow electricity to pass through it easily. If you try to pass electricity through wood, it will be difficult. If you want to pass electricity through a concrete block, it will be difficult. But if you want to pass electricity through a metal wire, it will easily go, right? So metals are good conductors of heat and good conductors of electricity. So these are the 4 basic properties: inorganic, crystalline structure, good thermal conduction, good electrical conduction. These family of materials are called metals. Yes, so we were here and I had by mistake pressed a slide and I could not have gone back, so I had to stop and then restart. So you see, there are metals and there are things called metal alloys. Anybody who can tell me, again, don't read further, right? That should be our habit, that if we are in this line, don't read further. So we have already defined metals. Anybody can tell me what is alloys? What is alloys? They are made of metals. But yes, if somebody knows about it already, alloys are mixtures of more than one metal or a metal and a non-metal. So suppose I have iron, right? Iron is a metal. I add some carbon to it. Carbon is a non-metal. If I can do that successfully, I get something which is famously called steel. And steel is an alloy. It is an iron-based alloy, but it is not pure iron, right? So metals, if we can mix other metals to it, or we can mix other non-metals to it in such a way that we get a good new material, then they are called alloys. So metals and alloys are divided into these 2 big categories: ferrous and non-ferrous. Again, don't read below. Don't read below. Ferrous and non-ferrous. Anybody, because you have done previous chemistry. What do we mean by ferrous and non-ferrous? By the way, iron, the metal iron, what is the chemical symbol for iron? Anybody? Yes, it is Fe. why is the symbol not IR? Tell me, oxygen is O, nitrogen is N, right? It is based on the name. So if the name is iron, it should be IR, isn't it? So why is the name of iron Fe? Anybody? Yes, those of you whose teachers have told you or you have read in your own books that the original science was in the Greek time, then in the Islamic Arab time, and later on when it came to the Roman time, then it was all in Latin, right? The Latin language. So many words are from Latin and Greek. So ferrum is iron, Ferrum, and therefore iron is Fe in the old things. So now, what should the word ferrous mean and what should the word non-ferrous means? If you are guessing it correctly, yes, it is called ferrous because it is like iron. It is not necessary that ferrous means exactly iron. Any metal or alloy that behaves in a similar way to iron is ferrous in nature, and any other metals that do not behave majorly like iron is called non-ferrous. Okay, so here we are now writing that if you want to name metals, then ferrous metals are irons and steels. There are more than one kind of iron. We will see many types of irons and hundreds and thousands of types of steels. So all of these are ferrous in nature, and copper, aluminum, some other metals and their alloys are non-ferrous. So without reading further, if I now ask you, yes, they behave like iron, so they are called ferrous. But what is the major property or properties of iron that differentiate it from other metals? Anybody? What are the specific? Now, so you will think that, oh, iron is a strong, other metals are maybe not so strong. Maybe you are right, maybe you are wrong, right? But we will tell you that some irons and steels are very strong, but then by materials engineering we can develop many aluminum alloys which have a very high strength. So then we are confused. We said initially that if they are very strong metals, then they are ferrous, but now I can make alloys of aluminum which are very strong, right? So this will not be enough. Try to think any one property or any two property, think on it, that which you think by your general knowledge of until now that iron or iron type of materials will have this property and others will not have it. Somebody is saying, suppose thermal conductivity and electrical conductivity, right? That you see, we know that all iron and iron alloys and steels and so on are very good thermal conductors and electrical conductors. But then if you go to the basic definition, this is the property of all metals. All metals are good conductors of heat and electricity. So you see, this will not do. It means that whether ferrous or non-ferrous, they are all good conductors. So can you think of any other thing? Yes, if somebody has said corrosion, you understand, rusting, R-U-S-T-I-N-G, rusting or corrosion. You see, right? If it is iron or a steel and you leave it in the open for a long time, several months, several years, then at the top outer surface some brownish reddish powder type is formed, and you said there is corrosion in the iron or steel, or this iron or steel has rusted. This does not happen in copper, this does not happen in aluminum and so on, right? So corrosion is, yes, a property which is specific to ferrous materials. Non-ferrous materials do not corrode. But remind me, you cannot remind me, I'll have to remind myself to talk of it later. Any one more property, you have already succeeded in finding one property called corrosion, which is specific to ferrous metals. Non-ferrous metals do not have corrosion generally. One more. I am trying to be happy just by assuming that at least one person in the class or more than one have now said magnetism. magnetism. You know what is a magnet? Magnet is a metal, a special type of metal, which attracts iron, right? Or attracts other metals, right? So that north-south pole thing and so on. So there is nothing like natural magnet generally. You know that you can take a piece of iron or steel and you work on it in a certain way and you can generate magnetism in it. Of course, naturally, in some rocks and somewhere there is some magnetism also. So magnetism, this north-south pole business, that if you have a magnet and there is a ferrous metal, it will stick to it. But if it is a non-ferrous metal, it will not stick to it. So magnetism is again a property which is intrinsic, special only to ferrous metals. Only to ferrous metals. Non-ferrous metals cannot be converted into magnets. So these two, corrosion and magnetism, are the two most deciding factors about whether a material is ferrous or non-ferrous. Other things are there, you can read it. High tensile strength, good durability, high carbon content, which can cause rusting, mostly magnetic, and therefore very useful for motor and electrical applications because they are magnetic. Non-ferrous, good in malleability and formability. This means that they are more ductile, they are more soft, that can be changed into new shapes easily. No iron content, of course, higher resistance to corrosion, non-magnetic, and therefore important for many electronic and wiring applications because they are non-magnetic, so we need it, right? So ferrous and non-ferrous are two big categories of metals and alloys. After that, we are just telling you that, you see, steels, I have already told you, is iron mixed with carbon. There is a large variety of steels. We can make hundreds and thousands of different steels, and therefore we can have a lot of industrial applications. That is why in the last class when I asked you that if you think of machines, from 4,000 years ago until today, which is the single most common material in the world, it is iron and steel. It is iron and steel, because we can develop different steels with different types of strength and hardness and magnetism and corrosion and this and that, and therefore we can tailor their properties to different machines. That these steels are good for cars, these steels are good for camera bodies, these steels are good for trains, these steels are good for aeroplanes, and so on. So therefore they are there. Now some words, big words, super alloys. You see, alloys, I already told you, are metals mixed with other metals and non-metals. Not, you see, remember when I say mix, it is a mixture, not a compound. If I have a compound of a metal with another thing, then it will be a new material. It will no more be the same thing. But if I mix some carbon to it so that the carbon does not chemically react with iron, so iron and carbon both remain together, but their properties change, right? Then it is an alloy. So just the name super alloys, because their strength will be much higher, their temperature resistance will be much higher, their resistance to creep and fatigue will be much higher. You see, the problem with me is today that because we are not in the class, now you have heard of these words, creep and fatigue, in different courses, because you have done basic courses in chemistry and physics and so on. Fatigue, you understand, fatigue is a type of load which is repeated. If you see a shaft is rotating, right? It is not just the load is up, so it is rotating, so it is going up, going down, going up, going down. So there is a fatigue loading, right? There is a fatigue loading. And similarly, when you have something called high temperature, then if the temperature is there for a constant long time, then there is something called creep. So creep means at high temperature for long time, and fatigue means at the same load but repeatedly.